Hello students, welcome to video lesson 5.4 and 5.5. We're doing two lessons in this video, talking more about area and perimeter, reviewing some things about area and perimeter of some more specific four-sided shapes. In this video, we're going to talk about squares and rhombuses. Now, squares is one of the easiest shapes that we have to find the area and perimeter of, so that's going to be pretty quick. Rhombuses actually have one special way that we can find the area of a rhombus that's sort of different than the rest, but we also can use the good old-fashioned base times height for that as well. So we'll start talking about the perimeter of these shapes. The reason that perimeter is so nice in these particular shapes is that for both squares and rhombuses, remember from chapter 4, that all the side lengths of these shapes are congruent. Okay, so all four of the sides are exactly the same length. So what we would expect to see in a picture would be something that looks like this. Like that. All right, so that would be marked, this would be marked, this would be marked, this would be marked. Same over here in the square, they would all be marked. And then, of course, each corner would be marked as 90 degrees in a square as well, or at least one of the corners would need to be marked. Okay, so because the four side lengths are all the same, remembering that the perimeter is just the total of all the sides, well, if they're all the same, then I can just take one of the side lengths and multiply it by 4, right? So that works for the perimeter of both squares and rhombuses. If you know one side length, you can simply find the perimeter by multiplying it by 4. Okay, so if I have a rhombus over here with a side length of 5 feet, the perimeter of this shape would be 20 feet. Right, 5 times 4, 5 plus 5 plus 5 plus 5 makes 20. Right, and for the square, if it was, let's say, 7.5 inches, the perimeter would be 7.5 times 4, which would be 30 inches. And remember, perimeter gets regular units because we're talking about length or distance around the shape. Now, when it comes to area of these two shapes, for squares, it's relatively easy because squares are just specific rectangles, and so we're still going to use the formula, that the area is equal to the base times the height. But in a square, because we know that all four sides are the same, we know that the base and the height are actually the same as well, right? This would be the base, this would be the height, but they're exactly the same length because this is a square. So what we can do is we have this other formula that just says area equals S squared, and that means the side length squared, or the side length multiplied by itself. So if we know that the square has a side length of, let's say, 3 meters, the area of this shape is simply going to be 3 times 3, or 3 squared, which is 9. And then our units now become meters squared, okay? So when we find the area of a square, as long as we know a side length, we don't need any other information, okay? We can just do that side length squared, or that side length multiplied by itself. And then remember that we have squared units. Now, when it comes to rhombuses and their areas, as I mentioned, we have two different options for how we find the area of a rhombus. Okay, one option is to do base times height, just like a parallelogram, because a rhombus is just a specific type of parallelogram. So remembering that the height of the shape needs to hit at 90 degrees, if we are given one side length, or the side length of the rhombus, remembering that they're all going to be the same, right? And then we also know the height, we can simply do base times height, and we would get, in this case, an area of 12 centimeters squared, because we do 3 times 4. The 4 is my height because it hits at 90 degrees, okay? So if you know the side length of the rhombus and the height, the vertical distance that hits the base at 90 degrees, you can just multiply those together and you're all good to go. Okay, so that would be, again, using this formula, area equals base times height. If you don't have that information, an alternative is if you know the two diagonal lengths. Okay, if you know the lengths of the two diagonals, you can find the area of a rhombus. Okay, now this actually also works with kites, but we're not going to talk about that in this video, or it's not going to be in your homework. But the formula for the area when you know the two diagonal lengths, I'm going to say lowercase d1 and lowercase d2. That denotes diagonal 1 and diagonal 2, but it doesn't matter really which one is which, okay? The formula is simply this. It's diagonal 1 times diagonal 2 divided by 2. Okay, it's diagonal 1 times diagonal 2 divided by 2, which is also known as, you could do it this way, you could do 1/2 multiplied by diagonal 1 times diagonal 2. Okay, so in this particular case, this example here that we have, the distance from A to C, we are given as 4 centimeters. Okay, so this is 4 centimeters. And then the distance from B to D is given as 9 centimeters, right? So this one from B to D, that's 9 centimeters. Sorry, that got off a little bit. So did that one. That's not too good. Let's see if we can follow that. Whatever. You know what I'm saying. This is 4, this is 9. So what we do is we just multiply them together. 4 multiplied by 9, and we get 36. We divide that by 2, and we get 18, right? 18 centimeters squared. So that would be the area then of this particular rhombus. With one diagonal of 4 and one diagonal of 9, it would have an area of 18 centimeters squared. Okay, and again, squared units because we're talking about areas. Now, if you have any questions about finding area or perimeter of squares or rhombuses using either of our methods for rhombuses, please let me know. Otherwise, that's all I have for you right now, and we will talk to you soon.